went over. Um, so primarily among these is wider deployment of GIS-based tools. Currently, most GIS users in transportation agencies, if you will, are those who do mapping and such as, which is very important, but um, planning and programming sections. This is like deploying GIS as a substitute for manual map production and is analogous from back in the day to the initial deployment of CAD to replace hand drafting, right? Um, however, similar to the way in which CAD became BIM, essentially, GIS has become more than just a way to do maps of the highway systems. So there is a potential. The technology is there. We just need to realize, and we just need to start get on the same page and use it. So the bottom line is that the proposed NRBM specification will not be just another report generated by the states simply to satisfy the FHWA requirements. So it is the actual data that is used within the state, um, regional, tribal, and local government transportation agencies, and it is structured in a way that reduces the cost of data collection, editing, and publication. So, like I said before, it's essentially the bottom line is to reduce the cost, but um, and it's reducing the cost by saving time for the agency by sharing, and so the way the data is presented to internal and external users. So it is the means by which very tedious, daunting transportation issues will be addressed by answering the old and new questions being asked. So essentially, like I mentioned, the bottom line is the cost. Um, so how is this done? Like I mentioned, um, for the GIS analyst and in particular in transportation, we use linear referencing. So it's all of the roads are links and nodes, and we're going to talk about that. But essentially, at its heart, it's linear referencing, which is used as an organizing element for data presented in a manner that simulates travel down a roadway. So linear referencing is a well-known manner for presenting data uh, to internal users at the state and federal level, and it's how driving directions and route information are presented to transportation data consumers, such as Google Maps and consumers using the distance between action points to referencing posted mile post values. So uh, yeah, but before I move to the chart here and explain about the data flow and what we're trying um, to do here, what FHWA is trying to do, I'd like to talk a little bit about the nature of the document that FHWA published back in 2019. So it's essentially a national transportation data set already. That data set already partially exists in a different form, if you will. And so this data set, which is available online from, let's say, the Bureau of Transportation Statistics or in the U.S. Department of Transportation. So the NRBM, or the National Roadway Base Map, could be used to display the attributes contained in the existing that's that we already have from the Bureau of Transportation Statistics. So in their data set. So along with the essential roadway data elements supplied by the states, let's say. So users would be able to combine the data from one or more layers in GIS, let's say, on a common roadway base map, while data suppliers would no longer need to produce application specific roadway center lines. So um, SIEM will be the conveyor belt that moves a transportation asset through its life cycle, with each workgroup station adding its contribution to the final product. So a well operating transportation system for the public. So there are so many. Right now, they're using BIM as being building information modeling, while they have another one called BIMI, which is BIM for infrastructure. And SIM, as I said at the beginning, I will use these abbreviations, meaning Civil Infrastructure Management, which is essentially a framework for data governance and management at the enterprise level. So SIM can be used to manage application, essential operation components such as policies, equipment, data, processes, human resources, and so on and so forth. And it'll build on the task-focused organizational structure and concepts for BIM and BIMI. So the large variation in business rules among the states has made it difficult for software vendors to develop a single product software that, excuse me, could be broadly marketed to them all. So as a result, specialized GIST, T meaning so geographic information systems for transportation, software is limited in functionality and also in varieties. Um, so a prerequisite for this type of software is a national market, and it's made by the states adopting common business rules. So the rules are, we can see later in this presentation, are here and shown in these guidelines, FHWA guidelines. So support for the for a national roadway database begin with the requirement for states to supply LRM or its linear referencing model based data with compatible geometry covering all public roads as part of their HPMS submission. So, however, the states are able to provide their own version of the LRM-based dataset, not one conforming to a single definition or structures. So, essentially, the intended audience for the AEGIST guidebook's primary audience is the state DOTs. It is intended to help their development of an enterprise GIS T infrastructure and creation of the national roadway base map that contains roadway center lines and essential data elements conforming to a published specifications. However, the target enterprise, if you will, is really the entirety of the many levels of government focus on transportation facilities and their use. So the ultimate goal of building a national multimodal map and the data it supports starts with adoption of shared definition and business rules. FHWA came up with almost 50 rules, 49 rules, and we will touch on some of them. But the intent of data governance should be to provide data interoperability. It's not enough for data to be shared. It must be the responsibility of the supplier to provide the information expected by the user accurately, on time, and in the proper form. This level of data management is called data interoperability, and it establishes the obligation of the data supplier to meet the needs of the data user. So it will not be enough to just say, here I made this data to meet my needs. You can probably use it, check it out. It should be, here is, I made this data for both of us to use. So again, we go back to the core value of this measure once and use many times. So for the civil infrastructure management sets, or SIM sets, the new context, the context for enterprise data governance is essentially the SIM. Um, and GIS initially deployed as a means of illustrating the content of those databases and is increasingly becoming the native roadway inventory database. We all work in GIS. We all share files, GIS files, to across agencies, between agencies and designers, between designers and contractors, and so on and so forth. So GIS, some states are using GIS as an input mechanism to provide environmental and roadway data to the design process, which uses BIM tools. So then GIS users are also consumers of BIM-derived data. So as a means of providing roadway inventory updates when a construction project ends, it would be beneficial for the BIM platform to then send the as-built information to the GIS platform, kind of what I mentioned at the beginning. The ideal data flow is shown in this um, figure or flow chart, if you will. And as you can see, let's say that the agency identifies the needs of improvements, let's say on the roadway. And that's done in GIS. They share this to the designer or internally within the agency, and they evaluate and present present and future conditions. So what is going to be? Then they essentially, the planners develop the conceptual plan, perform social and environmental analysis. So they do public hearings about the project. So then they identify the potentially needed right of way, develop construction plans, which is kind of between the contractors and the designers, get the right of way that needed. Then they move to perform the construction procurement. Construction improvements happen. This is BIM, this is BIM. Mostly is GIS and or uses both, but then after it's constructed, um, to update the facility inventory, this is a conversion that it's provided by the contractor to the agency in BIM, and then this needs to be converted into GIS. And then through GIS needs to be again operated, maintained, and all of the data that is collected, it needs to be represented in GIS, and then eventually evaluate the facility condition and operation. And once that's evaluated and the conditions are found, and if the facility operates at the desired level or below the desired level, then we go back and we identify the need, and so on and so forth. So you can see from the legend here which are GIS or both or BIM, but essentially these are like conversions that need to happen without sharing so many files, without making this process very tedious. And essentially the final goal is to get everyone on the same page, and that can be created through SIM, or the civil engineering, civil infrastructure management, that contains BIM, GIS, and like I mentioned earlier, Revit. It's now coming, kind of combining both um, AutoCAD, MicroStation, and so on and so forth. So all of this will be encaptured, and it'll be under the umbrella of the civil information management.